the R&D, like the research and development of the focus of the research team, I think it's more focused nowadays on the post-training, like getting more performance out of that, because it's more like the newer paradigm and there are still low-hanging fruits to be picked. Where in pre-training, it's already pretty sophisticated and you will still get better results if you use more data, optimize the data mix, maybe multi-token prediction and these types of things. But most of the interesting things are happening now on the post-training front in the reasoning realm, basically. So I think we will see more there.
All right, everyone. Welcome to another episode of the TWIML AI podcast. I am your host, Sam Charrington. Today, I'm joined by Sebastian Raschka. Sebastian is an independent LLM researcher. Before we get going, be sure to take a moment to hit that subscribe button wherever you're listening to today's show. Sebastian, welcome back to the podcast. It's been a little bit.
Yeah, thank you for inviting me back, Sam. I'm happy to be back and to chat about LLMs, AI, and whatever you have in mind. I had a lot of fun last time, so I hope we can make it fun and interesting again.
You know, my joke around this time, it's getting a bit old, but it's like the last time we spoke was 3 years ago. Not much has changed, right?
Well, all good things come in threes, I think. There's a saying, right?
And in fact, a ton has changed, and we're going to be focusing on the most recent and most important of those changes, in particular, what's new with LLMs and what to expect with LLMs in 2026. This is an area that you spend a lot of time focusing on with your research and education work. Um, Maybe we can start with just, kind of top of mind. Like if you think about, very big picture, where we are now compared to where we were a year ago, what is your broad reflection about the evolution of the space?
Would look at today compared to 1 year ago, it's almost like the anniversary of DeepSeek, the big DeepSeek version 3 model, accompanied by the R1 model, the reasoning. I would say reasoning revolution in quotation marks. It's still LLMs. It's still the same base model, but we have now more techniques on top of that to make the models smarter in terms of solving more complex problems. And so I would say architecture-wise, LLM architectures are looking still relatively similar. But the reasoning training is one of the new things if we compare today to last year. And then also, I think there's a more heavy focus on tool use. So back then, when ChatGPT was launched, or also the first iteration of LLMs, the focus was mainly on general purpose tasks, but then also having the LLM answer all the things we are curious about, like from memory. Like if we ask it a math question or a knowledge question, the LLM would basically draw from its memory and then write the answer. But that's not always, let's say, the most effective or accurate thing to do. Similar for us humans. I mean, LLMs are different from how humans think, but we as humans, if you ask me a complicated math question, like or just like a multiplying two large numbers, I would pull out my calculator and calculate that on a calculator. I wouldn't do that in my head. I maybe could, but it would take a long time. It's more error prone and so forth, and there's no need to do that. And the same with LLMs. Now with more modern tooling, it becomes more and more popular to use or to have the LLM use tools too. It requires training the LLM to use those tools, but with that, I think we can reduce like hallucination rates, not completely getting rid of those, but reducing those, and then also making answers more accurate. So, and then with reasoning capabilities, it's essentially giving the LLM more time in quotation marks to think through a problem. So these are, I think, the two main, I would say, uh, yeah, knobs that we can tune and to make progress on in the last year. If we look particularly like last year and now, the difference, yeah.
We'll dig into the technical aspects of like how we've evolved in reasoning and how we've evolved in tool use, among other things. But before we do that, I was thinking it might be interesting to talk a little bit about, from a practical perspective, how do you think where we are today is different and has shifted? And it's super interesting. We're talking in kind of second week of February, and already this year in 2026, there's been a ton of new news, new models, Opus 4.6, OpenAI 5.3. There's been the whole OpenClaw and Moltbot. Talk a little bit about the what we've seen already this year, but in the context of like where you see LLMs are from a practical perspective.
Yeah, I would say, yeah, that's a good point. We are just in the second week of February, and that means the Chinese New Year hasn't even like occurred. Where I think there will be also another batch of releases, but I think like on the open weight front. But I think that is like a separate thing where um, you have now companies developing the tooling around LLMs that is becoming more and more mature, and then you have better LLMs yourself. And I think I would also almost like separate those two. So my hypothesis is if you would take the best open weight LLM and put it into, let's say, a ChatGPT or Gemini or Claude interface, you would almost get the same type of quality, performance, and everything. Like where I think a lot of use cases evolve around the tool wrapper around the LLM nowadays.
That's this idea that was popularized kind of towards the end of last year around harness engineering.
That is also something how we changed using LLMs, because before it was just simply um, yeah, like a very simple chat
Give us some
interface. There was a model.
context and
Yeah, yeah, yeah.
yeah.
And then it became, more sophisticated. You could upload files and PDFs. And so for my personal use case, I use LLMs mostly for like, actually it sounds weird, but like proofreading, checking things, and these types of things. So just before we are recording here, I was finishing writing a chapter, and I wanted to update the table of contents, and then I just uploaded the PDF to the ChatGPT interface and say, "Hey, can you give me the headers so I don't have to pull that out myself?" And then you can just double check also that it is correct. But like little convenience tasks, like making work a bit simpler, like these tedious things. But then, like you said, there was also the new Opus model, and then ChatGPT released Codex 5.3 and a macOS app with that. And I think that is also like yet another leap in terms of what these models are capable of. I mean, before there were also coding LLMs, and it became more popular to use LLMs for coding, but it's always, more and more and getting better and better. And so before I used Visual Studio Code, I mean, because I just used Visual Studio Code, the code editor, for like years, like maybe 5 years now, 10 years, and before that I was using Vim and other things. But I'm very familiar with the UI basically. So I have my Git tree. I know where I have a terminal inside, and that stuff. And so I actually liked having the LLM as a plug in there, where you sometimes can say, okay, can you, I have a bug, can you just double check? It's just like another layer of tools you add to your workflow. So the LLM doesn't have to be front and center. It can be also this little helper, like before you, I mean, I still debug things myself, but often it's actually quite nice and fast to ask the LLM to double check things. And what I like about it is when it's like a second pair of eyes, but it's also like it's not completely taking over and doing everything. But it's making your work better in a sense. Like you have additional checks, and you can ask, hey, can you suggest improvements to make my code, let's say, more performant. Still, I mean, you as the person, you still have to kind of ask the right questions, and you still have to run actually the experiments to see whether it actually makes the code faster. So it doesn't mean like the LLM does everything for you, but it suggests useful things. I know a lot of people also use it for coding things, so that also works. With the new, let's say, the Codex plugin, but also the Codex app, what's new is, I mean, a year or two ago, people were uploading code files to ChatGPT or Gemini or Claude, and then getting some feedback, and then you had to manually incorporate that. And now it's more in line. Like
I
you
think it's been
can,
a while since
yeah,
folks have been doing that.
yeah, right. So that is now more native, where you can see the file diff. You don't have to leave your coding environment. But then on top of that, also now when you run these tools locally, you can give it access to your to your whole folder, let's say your whole Git folder. And then it can see the context of all the files. You don't have to manually upload anything. And then on top of that, it can also nowadays use tools itself. So you can give permission to the LLM to run certain commands, to run a unit test by itself, and these types of things. And that together, I wouldn't say there is a single thing that is like groundbreaking or like a game changer, but all these little things, they add up to make the LLM more capable, because it's more and more getting more and more sophisticated. And I think that's what we have been seeing in recent months, and maybe the last few quarters, months, where people, like, they develop these types of capabilities instead of just making the model better. So there's a lot of performance we can get from the LLM by making the the interface better, basically. Yeah.
Have you found that either of these new models, you just said that, there's no breakthrough changes there, but did you find yourself surprised with, some new capability in either of these two models, or is it, very much incremental to what you're already doing?
For me, it's personally more incremental. It's just more like the convenience. They're just getting more robust and better. Where I wouldn't say there is anything where it's like there's no wow effect to me. Like where it's like, oh, my previous model was not able to do X, Y, Z. It's just a bit better. It's getting more robust, more better. And then I also develop a bit more trust in the results. It's more like a gradual improvement, I think. The one thing is still we still have the distinction also between the different reasoning efforts in terms of it's like a slider in terms of how much time the LLM should spend on getting you the results. And there are different settings from low or no reasoning effort to high reasoning effort. And that changes the time it takes for the LLM to generate results. And I remember like half a year ago, if you wanted to have good results, you almost always had to use the highest settings, the high reasoning modes, which took forever. Nowadays, even the lower modes, I feel like, are pretty good. Like where for most tasks, it's sufficient to use these medium, high reasoning efforts instead of the extra high ones, and then you get results faster. And I think that's also like a quality of life improvement for these models, where before you ran them maybe occasionally because you don't want to wait 5 minutes, but now it becomes more routine that they are part of your uh, workflow, basically.
I would expand on that and say that the LLMs have gotten really good at themselves knowing how much effort is required to provide a good answer to a query. And so I find myself, in the vast majority of times, just, typing my prompt into, ChatGPT, for example, and not specifying a model or level of thinking and letting it figure it out. And if I want more, I'll tell it I want more. Um, but it does a fairly good job of determining when to just give me a quick answer, when to use a search tool, when to, do more thinking, that kind of thing.
I agree. I have my setting on ChatGPT the auto mode, where it automatically or it by itself decides whether it should use more or less thinking effort. The same thing. The only context where I still use the pro mode is when uh, coming back if I to the chapter I mentioned, when I have a chapter written like a 40-page PDF, I would upload it there and say, "Hey, can you check for any inconsistencies, incorrect numbering, and all that type of stuff." And then I set it to the pro mode, like the one that takes 20 minutes. I go have a lunch or have dinner, come back and look at the results. Where there, it's like a rare thing that I do that. I mean, once a month I finish like a chapter or something, and or like if I write something important, where I want like the maximum, let's say, quality check on that. But like you said, for most tasks, it's sufficient to use the light effort, yeah, or the automatic one where it decides by itself, essentially, yeah.
And I mentioned Moltbot and the release of that tool. Have you spent much time digging into that?
Well, yeah, Moltbot, I think now called OpenClaw. So the
OpenClaw,
name
yeah.
changed. Yeah, yeah, it changed a bit, quite a bit. It's interesting. It's like this local agent that people can now run on their own computers. Where I think that what I find interesting about it is it gets people excited about things. It's almost like back then when DeepMind had AlphaGo, like the Go playing, it's like a board game, like the Go playing, model, where yeah, it got really exciting because not people. I mean, there are not many people, let's say, in the grand scheme of things, that, or at least in my circles, who played Go before. But it got people like my family and everyone really excited to see this type of progress when it was playing against the world champion. I think with Moltbot, it's kind of like similar, where it gets people interested in checking these things out and excited. Um, I think there's also a lot of genuine use cases around it where you can run it, I mean, to organize your calendar and emails. For me personally, that's something I have not done. Maybe I have a little bit of a trust issue, where I'm like, yeah, I mean, personally, it's like, yeah, well, I don't know if I trust it enough to do my finances or my calendar. A bit, I'm a bit hesitant still to adopt something like that. But I think it's a cool demonstration of what, and like, to kind of like show someone who is, let's say, also not developing LLMs, what these LLMs can do and what the purpose of those is, also, in a sense. I think that's actually quite cool. Yeah.
Any other tools or services that are largely kind of wrappers around LLMs that you have come to depend on, or do you find yourself mostly turning to the models themselves, or like the dev environments?
Yeah, it's mostly still, for me, for my workflows, I don't have anything like super automated where I'm like, I need to run something incrementally or in an agentic type of setting. What I've been doing a lot though is developing my own apps, like productivity apps. I think back in the day, I grew up as like a coder, like using Bash, the terminal, and Python and that stuff, where I was writing myself, like for myself, like scripts for all kinds of things to automate things. And now with LLMs, I kind of changed that a bit towards developing native macOS apps. Like I always wanted to learn Swift coding in Swift. I've never had the time because, yeah, I mean, there are so many other more important things to do for me. Where like that was an opportunity to say, hey, I want this, but I have as a script as a native macOS app because it's just more convenient. For example, just the other day, my wife also has a podcast. It's like a book club podcast, and I help her with the episodes, basically, like uploading everything and editing and like just the workflow in general, because she's not like a tech person. And then I had like a script to add these chapter marks to the podcast. And now I made just the other day, a native macOS app where you can just add the timestamps and click a button, and it adds the chapter marks to the audio file. Like simple things like that, and then I can share it with her, and she can use it now. And it's just like these little quality of life things in your everyday life, where you, instead of just doing things manually, you can just automate them now. I mean, not necessarily. I mean, this is not running the LLM, but it's using the LLM to develop something that behaves deterministically, in a sense. So I'm more like of that, more like a person like that who does that. For example, I also have, when I read social media feeds, I mostly, as a researcher, interested in papers. So I often end up bookmarking a lot of archive links, links to archive PDFs or the abstracts. And then I have my markdown sheet where I have a lot of these links. And now I wrote myself a native macOS app where I just put in these links, and it pulls out the title, the date, the author names, and the link in like a nice format, and just making my life easier, so I don't have to click on them individually. I get a nice list and see the titles, and yeah. And I think little things like that, I feel like LMs are super cool for, like, to develop these tools that I would not have time to develop otherwise, basically. Yeah.
That parallels my experience quite a bit. I think some of the most benefit I've gotten out of LLMs in the past year or so has been writing kind of custom workflow tools. So primarily around the podcasts, like one of the things that we would do when we work with sponsors is like pull these analytics reports, and it was repetitive and time consuming, and so I created a web based tool that will hit the API where we get the analytics, um, and pull information about episodes. And you can choose an episode, and then we've got it'll pull a bunch of data into pandas and like do some analysis and then generate a spreadsheet, like a Google Doc. And like it doesn't, the app isn't using an LLM, but an LLM was used to create it. And that's one example of probably like half a dozen, you know, fairly significant tools that, have a big impact in our workflow.
Yeah, and that's a good point also, like that you said again, also that in these cases, the LLM is not doing the, let's say, regular work, the task, it's more developing the tool to do the task. And I think that's also an important point, in my opinion, that, well, the LLM is very useful and very capable, but there are tasks where it's almost like wasteful to use an LLM for that. Like it's like if all you have is a hammer, everything becomes like a nail type of situation. Where I do think if you have like a deterministic task, it still makes sense to develop a deterministic tool. You can use an LLM for that, but it is almost like wasteful to also even ask an LLM what is 1 plus 1 or something like that. You can use a calculator. So it's like, I think, yeah, it's still important kind of to recognize what is the nature of this problem and what is the best tool for that problem, basically. Yeah.
I've also done some tools where um, I'll use LLMs and like, almost like a classifier, like a very simple use case. I have one where it's like there's the name of the guest. So, your name, and then I pull a bunch of recent directories from the Google Docs API and say, find the directory that corresponds to the project for this particular, guest. Um, and it's like, a regex or like a text pattern match doesn't always work because they can be different sometimes. But an LLM, like, can do it pretty easily and, with a very high level of repeatability and a low error rate.
Well, it's like where you need almost like a human or like some less structured approach. Then LLMs are great for that. I had actually a similar project as a college student. I was doing sports prediction as a side project for fun, just for fun, like daily fantasy sports, like predicting outcomes of like which player scores a goal in the Premier League soccer on the weekend, like daily fantasy sports. And for that, I was also developing this very sophisticated thing, which was pulling information about the players from different websites and looking at who is injured, who is in I don't know, good form, and these types of things. And for that, and now I kind of revived that project just for fun using an LLM. It's kind of like the same problem you mentioned with the names, because some players have like the spelling of the name is slightly different. There are these accents over certain letters and sometimes not in certain databases, and then just getting them lined up in the database, it's really hard with regex or just deterministic things. So that is actually a great use case for an LLM to kind of these unstructured, almost like, yeah, vague data set parsing things that depend also a bit on the context, basically. Yeah.
So maybe kind of pulling back into like where we are with, LLMs from a practical perspective. I think both Sam and Seb are using them in very kind of, well, I think two main things came out of this. One, if you I was going to actually caveat this by saying if you are of a development mindset, but I think we've seen with like vibe coding that even less technical people or non-technical people can get a lot of value by creating custom tools to automate specific parts of their workflows. So that's a huge thing that I think has been very impactful for both of us over the past year or so. Um, and otherwise, just kind of taking advantage of the improvements in models by, for me, it's just like I can't really articulate like a rule set, but like for if I'm confronted with a particular thing, I have kind of a soft mental model for, yeah, I think I'll start with ChatGPT here, or I'll start with Claude for this or that. So I think the takeaway is that neither of us are, using OpenClaw or any, particularly, slick LLM wrapper agentic tools with any regularity. Maybe the caveat for me would be something like a Circleback or Granola to do like meeting summaries. But beyond that, it's mostly, like you described, use cases through the native chat interfaces, and the development oriented use cases.
I would add maybe also one more thing. You mentioned so it's also mostly a slider. Like you can use LLMs not at all. You can do still everything manually. Then you can only use LLMs. Like I know some people who develop, let's say, even a company just based on LLM code. People call it vibe coding, but like I think vibe coding doesn't even do it justice anymore. But like not doing any manual coding anymore, just using LLMs, like having the LLMs build the website, the product, and everything. So like these two extremes, and I think we are more like in the middle, where we kind of adopt LLMs, but we are not like, let's say, going full LLM. And I think for me also, I think there is still like I mean, I would say also for people who are nowadays learning how to program and like like is it worthwhile? And I think it is actually still worthwhile to learn math and coding, even though there are LLMs that can do that, because it makes your life also still more efficient, and it makes you better at using these LLMs. Because, like an example, I was using an LLM for my website to add a dark mode. So that's something I always wanted to do. I wrote the website myself like 12 years ago, but then, well, I knew HTML and CSS and JavaScript much better back then than I do now, and I always procrastinated on adding a dark mode button because I knew it would take me like a month maybe to do it well or something like that. And it's not my main, let's say, job. So I was like, okay, I can't spend that much time on it. But then I was like, hey, let me try using an LLM for that, and it did a really good job adding it, but it was not perfect. So the button was misaligned and everything. And then I was like, hey, make it a bit higher, make it a bit lower, edit, move it to the left. And like, okay, this is actually, I thought, very inefficient. Why don't I just go into the HTML or CSS file in that case and adjust the settings there? And because I still knew a bit about CSS files, I was more effective to make these adjustments myself instead of having the LLM do everything and just brute force telling the LLM, "Oh, move it that way, move it this way," and I could just change them on myself and refresh the page and see. And I think in that sense, it does make sense still to have like an understanding of how these things work, because then there are cases where it is just more efficient to do things yourself still than prompt the LLM to redo everything. And so I think the what I wanted to say is that there's a middle ground basically where I do think there's still value in learning how things work.
I wonder what your experience is. I'll often see around these new model releases on social media. Oh, I one shotted this. I one shotted that. Like I'm trying to remember the last one that I had this experience, and then I'll go and try and one shot the same thing, and the results that I get are horrible. Like nothing like what is reported in social media, and you know, like, hey, is it me? Like, or is it just people like reporting these successes for engagement and they're not really there or they're fake? Like, what's your sense for? Do you experience similar things?
Yeah, I would say so. I think, I mean, I mentioned my native Mac apps, even like something, I have a Mac app where I just put in a PDF and it exports the PNG, WebP, and PDF versions in a certain resolution. And it took multiple tries, even with, there was back then Codex 5.2, to get really everything, all the buttons working correctly. Like you said, it was not one-shotted at all. It was multiple iterations to get it to work, and even something simple like that. And then I sometimes wonder, are my instructions maybe bad, or maybe I wasn't clear? Maybe you have to say, please test everything thoroughly and make sure everything works, and blah blah, blah. Maybe you have to be super explicit about that, and we are not that explicit because we kind of assume it would make sure everything works. Or maybe these cases we see are just lucky. Like sometimes on certain things it just happens to work very well. So I don't know for sure, but I agree with you that it's not all what it seems when someone shows you, "Oh, I one-shotted this." I don't think that's reflective of how things work today. Yeah.
So let's switch gears a little bit and talk through some of the key areas that you expect to see continued innovation around with LLMs in the upcoming year? And then, for each of them, we'll dig in and talk a little bit about the recent history and where you expect to see things going.
I would say it's still gonna be the reasoning. We can maybe go into more detail there because it's a very broad topic. So pushing more on the reasoning front, the post training. The second one I would say is also inference scaling, like more sophisticated techniques that they are partly related to training, but mostly how to use the LLM after training. And then I also think we will see more of this, this agentic type of use, like how because right now mostly LLMs are focused on like a turn by turn and how to people will double or companies will double down on this loop, basically running LLM as a loop, like Moltbot and optimizing for that. And I think these three things will be mainly the biggest, I guess, focus areas for companies. Yeah.
Awesome. So let's dig into reasoning to set the stage for where you think we'll be heading in 2026. What do you think were the big advancements in 2025 around reasoning?
So yeah, the biggest advancement was, first OpenAI o1, which got everyone excited about it, and then OpenAI o1 was using both inference scaling and no one knows for sure because there's no paper, but likely also training techniques. But then R1, DeepSeek R1, they published their the reasoning pipeline, and I think that was really something that took off, where a lot of other companies also doubled down on that, but it's still very new in the grand scheme of things. It's just like a year old, and there have been. I was recently working on a chapter on reasoning. There were so many improvements to the algorithm. Uh, I just the other day compiled a list of 15 different tweaks and improvements, from basic things changing sequence level lock props to token level, but then also GDPO by NVIDIA. Lots of progress there, and I think we will see more of that. First, also, one reason is that with pre-training, we have seen basically that, it still works, and I think it's still the biggest part of the pre-training, of the whole training pipeline, because it's just so much data and very expensive. But the R&D, like the research and development of the focus of the research team, I think it's more focused nowadays on the post training, like getting more performance out of that, because it's more like the newer paradigm and there are still low hanging fruits to be picked. Where in pre training, it's already pretty sophisticated. Where, yeah, you still need a lot of data, you still need a lot of compute, but there is no, let's say, there's nothing you can really do much there compared to post training in terms of changing up the algorithms to get more performance. Of course, you can still do that, and you will still get better results if you use more data, optimize the data mix, maybe multi-token prediction and these types of things. But most of the interesting things are happening now on the post-training front in the reasoning realm, basically. So I think we will see more there.
On the reasoning front, one topic that I heard about, I heard come up quite a bit last year, is the idea of verifiable rewards. And I think that led to a lot of the advancements, or contributed to a lot of the advancements that we saw in terms of coding models. Can you talk about that as a paradigm and some of the big milestones that we've seen there over the past year?
Yeah, thank you for the question. It's actually it's a really really important point. Like, so the reasoning training is essentially mainly based on verifiable rewards, which means there are tasks where you can verify the answer. So, for example, in DeepSeek R1, the verifiable rewards were coding and math. So with math, for example, you ask the model to output the final answer in a boxed format in the latex. It's like a latex command, like boxed. And then you can have like a deterministic, like a regex or deterministic code to extract the answer. And then you can use something like Wolfram Alpha or SymPy to compare this answer symbolically to a reference answer. Like if 2 over 3 matches 2 over 3, or 4 over 6 matches 2 over 3, it's essentially the same answer. But you can symbolically double check the answer and get a reward signal, whether it's correct or not. And this is actually great because you can kind of like infinitely, you can evaluate infinite numbers of answers, because before with, I mean, it's still an important point, but the reinforcement learning with human feedback, yeah, you need human feedback, essentially. You can train a reward model to approximate that, and it's part of the training where you get a score for each answer, but it's not quite as, let's say, accurate as a really correct answer, like where you can verify the answer. Like there's an absolute, it's math, it's either correct or not. And you can have, if you have something like that where you can verify the answer deterministically cheaply, you can have the LLM generate infinite answers. You can say, okay, generate 60,000 answers for this problem, and then you can calculate the reward on all of them in a fraction, like a very short time. It's still expensive to generate these answers, but you don't have vagueness, and you don't have to have, let's say, human evaluating these answers. And so I think that helps scaling these things. And the same with code, where with code, in the DeepSeek R1 paper, the original approach was to have the code and make sure that the code compiles, basically, like if it compiles correctly. And you can use also a code interpreter for that. Um, I think, I mean, both are great, but I think this is just the beginning. I mean, we will probably see this being extended to have more than just the correctness of reward. I mean, there are already other types of rewards that are being added. For example, a formatting reward, where you want the model to use. I mean, not every, it's not required, but some companies prefer to have the thinking in the think tags. So they have like a token think, and then a closing token think closed, like in HTML, like the opening and closing tag. It's not required, but it can be helpful to have it, because then you can parse out the intermediate stuff and do something with it, where you can train the model to output this structure. And that is like, it's called a format reward. So you can have multiple types of rewards added to this thing in addition to the correctness reward. And I think we will maybe also see interesting things there, where people will come up with formatting rewards or like auxiliary rewards that help the overall model to learn. And one thing is also, they tried that in the DeepSeek R1 paper to evaluate the answer explanation instead of just looking at the final score, or the if it's correct or not. Um, Making sure, or like evaluating if the reasoning, like the explanation, is correct or not.
It's
And
like a process reward.
exactly. Yeah, they use what is called process reward model. That it's basically another model that you train to give a score for this explanation. But I remember, I mean, it's been a while since DeepSeek R1 came out. In the paper, they had a section that they listed that as a failed attempt or unsuccessful attempt. So they tried it, but they thought, okay, this increases the chance of reward hacking. And then it was just not worth it. It's more expensive. It resulted in reward hacking, the model exploiting thing, because it's yeah, it's easier that way for the model to kind of cheat, to kind of mislead the model that evaluates the model, basically. And so it is still tricky to do that. But I think also in the recent months there were some more yeah, interesting success stories, like DeepSeek Math version 3.2. They used something like that, where they evaluate also like the whole answer with a rubric. Have another model for that, and then they have another model that evaluates that model that has the rubric and so forth. It's like multiple levels, and but that seems to work. And they had like ablation studies that showed that this is actually helping. And I think we will see also more of that. It's just like a very new paradigm, like making the reasoning training more sophisticated, essentially. Yeah.
Right now, the verifiers are focused on like math and coding, and that's because, they're, for a given response, there's a concrete uh, ability to verify. Do you see this verification paradigm expanding beyond math and code? And I think, in part, the focus on math and code is successful because, even though not all LLM responses are about math and code, those things kind of have an inherent, logic or um, reasoning capability in them. And so the ability for the model to reason generalizes to, non-math and coding problems. But do you see a focus on expanding this idea of verification beyond math and code types of problems?
Yes. So it's actually a very interesting and important point. how can we? I mean, you mentioned that if you train the model on math problems, reasoning on math, it will also become better at reasoning in general. But then it would be even better if you have a target domain to train the model specifically on that target domain, on reasoning in that target domain. I think you're right. There will be more of that. For me, right now, I just lack the creativity right now to come up with example of problems that can be verified. But I would say maybe something even like biology related, where for like drug design, like pharmaceutical drug design, protein structure modeling, where you have like physical constraints. So there are like the angles between atoms, they can only have a certain angle and so forth, where you could probably have like a physics type of equation that double checks whether the generated molecule adheres to these certain types of formats, and then have that as a form of reward when you're training the model. I mean, this is maybe not a typical case of reasoning because, well, what is the reasoning explanation when you're generating a model, right? I mean, but in general, like something like that for other fields. And in the worst case, you can always, I mean, this is more like a rough approximation, but you can always train another model that provides the correctness reward. I think this is more challenging though because it's susceptible to reward hacking, even going back in the day, generative adversarial networks where it's easy for the generator to collapse. You have the discriminator, which says, is this image real or generated? And then it was like the setup where you train a generator to fool the discriminator, and the discriminator gets better at distinguishing. And you have like, almost like a similar setup. You can use it to say give a reward or not, but then the model may or may not exploit it at some point. Learns a trick. If I only generate this one word or something like that, then I fool that evaluator. But I think maybe we'll see also more of that, like developing like AI based reward models essentially that can be used then in other fields to train better reasoning models.
Beyond increased focus and tweaks to the verification models, are there other areas that you see as contributing to uh, stronger reasoning going forward?
Yeah, I do think it's also. I mean, the training is one part, but the other one is the inference scaling. That you can get much better performance if you use simple, let's say, not simple. I mean, simple in quotation marks, but if you after training, if you spend, let's say, if you have the model, if you spend more compute, essentially, like inference scaling is all about the definition is essentially spending more compute after training during inference when someone uses the model to generate the answer. And you can do it in multiple ways. I mean, reasoning models themselves, they are already kind of like a form of inference scaling because they generate more tokens than regular models. The explanation is longer than a regular model provides, and but it helps often the LLM to reach the correct answer. But this is more like a sequential inference scaling. You can also have parallel forms of inference scaling where you just generate multiple answers, and that's called self-consistency. So, for example, if you have a math problem, you can have the LLM with different temperature settings answer the question multiple times, and then you take a majority vote or something like that. I mean, there are different ways you can do it. There are different scoring methods or other LLMs that look at all the answers and give you the most likely correct answer. And with that, you can also boost the performance of the model. It's more expensive though, so it's always like this. Yeah, it's not like a one size fits all. You don't want to use it all the time. It's you use it when you need it. But I think what will be interesting is to improve the way to tell when it's needed. I think when ChatGPT was it 5.1 or 5 launched, they had like that automatic setting that we talked about in the beginning. It was very bad at the beginning, but I think it got much better over the months and years. And I think um, I'm not quite sure we have anything like that in the open source, open weight ecosystem. Maybe listeners may correct me here, but I think something like that I can see also being more important because yeah, on the one hand, we are developing these very expensive models that can solve very hard problems like in this math Olympiad, but we don't want to use them all the time because they are slower and more expensive. And there's also going to be more like a focus at the same time on cheaper models. So, for example, just the other week, Gwen 3 Coder Next, or Next Coder, sorry, Gwen 3 Next Coder came out, which is Gwen 3 is one of the most widely used open weight models, because they have like a lot of really high quality models in all different types of sizes. But they also, the next model, it is essentially like a hybrid. It's not like a pure transformer anymore. It has it's inspired by state space models to make things cheaper. But then it's like always this trade off. People are developing higher accuracy models. People develop cheaper models, and I think yeah, I mean, one way would be changing the architecture to control the quality and price. The other one is inference scaling. But I think right now it's in the open weight ecosystem, it's not quite as popular yet. So I think we will also see more of that in local tools and so forth.
I don't know that I know of any like a open source project or a model that incorporates this, but from conversations, I do get the sense that a lot of companies that are building around, the Quen models, for example, and these open weight models, uh, commonly have like a router component in their architecture that tries to assess the complexity or category of a prompt and routes it to the right, model and prompt. Uh, that is, either most economical or, maybe post trained for better responses, that kind of thing. My sense is that that's the common approach to addressing this challenge that you're describing.
Now that you mentioned that, another example came to mind. It's the GPT OSS model, the open source model by OpenAI, which came out last summer. And in that model, even if you use a very simple inference or like a simple tool like Olama or any comparable tool, you can set the reasoning effort in the system prompt. So you can say no, mild, medium, high reasoning effort, and then scaling inference based on the reasoning effort. But I don't think there's any other technique really automatically incorporated like self-consistency or self-refinement. It's mainly you have to, as the researcher, do it yourself most of the time.
Can you talk a little bit more about the self refinement and self consistency and how folks use those techniques?
Yeah, so self-consistency and self-refinement are two examples of inference scaling. I would say the biggest difference between the two is one is a parallel technique, where self-consistency as a parallel technique generates multiple answers. And you choose, let's say, the correct answer based on majority vote, or you can have a scorer who assesses these answers. But then people call that technique best of n, like best of n
Okay, best
answers.
event or
But
quorum or
yeah,
that kind of
yeah,
thing.
it's essentially an ensemble technique, um, like classic ensembling almost. And the other one is self-refinement, where you have the LLM generate the answer, and then you feed the answer to another LLM or to itself, and say, here's the answer, this is the question, write a summary if the answer is likely answered correctly, and what are weaknesses, and like a rubric almost. You provide a rubric with certain things that the LLM should check, and then it gives you back a report and says, well, this is could be better, this is likely incorrect, the explanation doesn't match the final answer. And then you feed that output back to the original LLM and say, hey, look at that report and refine your original answer based on the report here. And often this can lead to the LLM improving its own answer. It's almost like this phenomenon. uh, Sometimes you ask ChatGPT something and it gives you something, and like, wait, that can't be right. I don't know. You ask something about like when was a certain model released, and okay, this can't be right. The year is totally wrong, and you tell ChatGPT, hey, you are incorrect. You made a mistake, and oh yeah, you are right. I made a mistake, and then it tries again, and it's better next time. And it's almost like that same mechanism where um, yeah, it itself refines its answers. It can, I mean, based on my experiments, it can also sometimes make answers worse. Like it will overthink, or it was originally correct, but then I don't know, the feedback is weird or bad, and then it makes the answer incorrect. So it's not like like, well, not a foolproof technique. It's also with caveats, but In the DeepSeek Math version 3.2 paper, where they had a self-refinement in a more sophisticated way, where they had a third model evaluating the evaluator, they really showed, I get a nice graphic or a plot where they showed how much the accuracy can improve. And basically from I don't know the numbers off the top of my head, but if they cranked up the self-refinement and self-consistency, they were able to have like gold level performance in certain math competitions, which was very impressive, given it was still the same model as they used before, but they just cranked up the inference scaling, basically.
One thing that's interesting, kind of reflecting on these themes that we're discussing, is just how they're all very interrelated. So reasoning is a key theme. Reasoning is enabled by inference scaling. Inference scaling, a lot of what we're hearing as we talk about this is like loops and recursion and those kinds of ideas. And those are key ideas in the third key theme that you mentioned, which is kind of agentic uses of LLMs. Um, with that as a segue, talk a little bit about what you've seen thus far around agentic and what you think is exciting in that space.
I would say, yeah, the agentic use cases, it's even like simple. I mean, no, again, in quotation marks, simple things like Codex or Claude Code, where it does just multiple iterations to solve a problem. It's not just like one shot. It's more like doing a task, like rather than just providing an answer. And I think, I mean, Moltbot would be another example of agentic systems that have I mean, agentic is also like I would say almost like a not well-defined term because people use the term differently. But for this podcast, maybe we can think of agentic as something that runs in a loop. And I think, yeah, that is something we will see more of. Recently, Claude Code and GPT 5.3 Codex, the app, they added a lot of these tasks where you can even schedule something and it does something on a reoccurring basis, for example. And I think we will see more of that. It's just like the beginning. It will be more like plugins. And I mean, it's still the same LLM. It's just like how we use the LLM and how to get the most out of it, out of the context, feeding back the context. And I think there has not been that much focus on this in the open weight, open source community. The focus there is more on developing the LLM itself, where companies, though, that like, OpenAI, Claude, they are more like, okay, let's build these tools so we can actually do more and more impressive, bigger things with these LLMs. And I think maybe by the end of the year, we will have systems that can reliably book a trip to, some holiday or vacation destination where this becomes more common. I mean, there were already tools that promised to do that. I forgot the names, but I think it was called Devon, something like that. It might still exist.
Or Manus.
Oh yeah, Manus, right? Yeah, yeah. But I think that it's just like the beginning, and also most people, I don't think they need like a full blown thing that can do everything. They just maybe need like a plugin for Excel to have certain intervals where it updates certain things, and then Excel spreadsheet goes into the, let's say, goes to the internet and pulls the recent stock price or something like that. But like in a type of loop type of setting, essentially. Yeah.
One of the things we heard a lot about in the context of agentic uses of LLMs, I think over the past year, maybe 2 years, is the idea of like multi agent systems and like decomposing a problem into independent agents with kind of their own personas and that kind of thing. And I think that the whole or OpenClaw idea, like even like today, I'm seeing a lot of, hey, I created my AI team, and there's this employee, my AI employees, right? And there's this employee, that employee, and they talk to each other using Slack or Moltbook or whatever, and like um what have you seen with regards to, kind of from a concrete, builder or technical perspective, this like multi-agent uh, use case? Are you finding, folks getting a lot of value out of that?
To be honest, I wish I had a really good answer or interesting answer, but this is something I've not explored personally, where most of my experiences are like single use case, where it's one LLM that provides solutions or tackles a specific task, but it's mostly not interacting with other agents. I think um, here, though, I mean, I also see it's more like a context engineering problem where how do you, I mean, so the LLMs themselves, I don't think they are the bottleneck. It's more about how you, let's say, provide the result, get the results and provide them to another LLM. I mean, in that sense, it's almost like a form of when you do image or video generation where you have one LLM parsing the text or improving the input and then passing that to the LLM or to the part of the model that generates the output, the diffusion model part or the transformer based diffusion part, where I think it's more like a sophisticated form of that. How do we provide the right context to the different agents? And it could be from basic databases to using Slack, where one model outputs something there, and with the via the API, the other model ingests it. And I think, well, that is, I think, also something that is just getting started, also with Moltbot and or OpenClaw, and I think we'll be seeing a lot more of that. But yeah, so that's all I can say to it because I personally don't have any concrete experience. I haven't worked on this myself yet. Yeah.
Do you have a sense for where we'll see focus and innovation around these kind of agentic uses in the upcoming year, or maybe what the gaps are, what really needs to be worked on in order for them to kind of come into their own?
I do think it's still like each LLM has its own kind of like failure rate at some point where so the progress is usually measured how long the LLMs can work autonomously, like how long can they work until they fail. And the more models you add, the higher the risk that one of them fails if they depend on each other. And I think um, improving the model itself here will also help improving the whole system basically as the main way to improve the performance. But then I can also see right now most, as far as I know, based on what is publicly available, these are still the vanilla LLMs that are in Claude or in other APIs. They're not specifically trained to interact in a multi-agent setting, and I think in that sense, if you prepare data for training these agents in a multi-agent setting, like a fine-tuning type of situation, I think you can also get more performance out of them. We have seen that. I mean, even for simple things like codecs. Uh, GPT 5.2 or 5.3 codecs is not the same as GPT 5.2 and 5.3. These are models that they forked off and then specifically trained to work with the Codex app, basically. And I think something like that we will also see for these agent models. It's just harder for, let's say, the consumer to do that because you don't, or we don't have access to these models. So we kind of like dependent on the person who owns the LLMs, who hosts the LLMs to do this type of training, basically. So yeah, I think I can see companies also developing something like this. I mean, if I had to bet, Claude and OpenAI, they really paid attention to what Moltbot or OpenClaw is doing and maybe coming up with their own version of that that is maybe even more capable because they control the model and they can fine tune it for certain interactive multi-agent types of environments.
One of the things that's interesting looking back is that a lot of the things that we might look back and see as big advancements over the past year or 2 years, from an architecture perspective, they're relatively incremental. Like the fundamental core architecture, there have been a handful of proposals of like where we might go beyond LLMs, but the core has been fairly stable. Do you agree with that? Where do you see, how do you think about the future of LLM architecture?
Yeah, that's a interesting question. So I would say everything I'm saying here with an asterisk because DeepSeek version 4 is not out. It might change everything completely in terms of what I'm saying. But if we just look at 2025 up to the second week of February, I don't think there were any fundamental changes in terms of the state of the art architecture. So I think one thing we have to distinguish between is like there are architectures that are more geared towards doing the same thing more efficiently, and there are architecture changes that are geared towards let's get more modeling performance accuracy out of the model. If we first, if we look at those models that push the state of the art, the modeling performance, there haven't been that many changes really recently. I mean, looking at 2025, mixture of experts models have been making a comeback. I mean, there were other models like Mixtral and DeepSeek MOE before, but they really became popular after DeepSeek version 3 came out. And DeepSeek version 3 became popular because of DeepSeek R1, which is basically a fine-tuned version or post-trained version of DeepSeek version 3. But then a lot of companies adopted this architecture. I think Kimi straight up used that architecture and they scaled it from 670 billion to 1 trillion parameters. Or even like the European company Mistral AI, they used DeepSeek version 3 architecture. So a lot of people are, I would say they are not gambling in that sense, and let's try something different. Or they take something that works and try to make progress or differences in terms of changing the data and the algorithms. But that doesn't mean there are no new ideas. So, I mean, DeepSeek version 3, besides MOE, the mixture of experts, they did have the multi-head latent attention. I think it was also in one of the previous papers, but multi-head latent attention is essentially like a tweak of the attention mechanism where you have like a intermediate, smaller, compressed state of the keys and value queries and keys. No, sorry, keys and values. Keys and values. I mean, all of them actually are, but the keys and values are important to compress because then your KV cache becomes smaller. So you don't store the full keys and values in the KV cache, but a compressed form. But then you reconstruct the keys and values from the compressed form in inference. So you are basically trading off compute with memory. But also maybe to explain this a bit better, you can think of it as LoRa, like the low rank adaptation. So basically, you project it down into a compressed space, and then you project it up again. So that's basically multi-head latent attention. That's like an interesting tweak. I think in 2025, 26 that people adopted, and then it was again DeepSeek version 3.2 that had another, I would say, tweak, sparse attention. I mean, sparse attention is also not new, but there's always been this like research on how we make attention cheaper because it scales quadratically with the sequence length. And there have been hundreds, if not thousands, of papers. But with papers, I'm always a bit. I mean, the ideas are interesting, but I'm always a bit careful, and I'm waiting always to see that in production, in quotation marks. What I mean is to see it in a flagship model, like because the idea might work well if you are only focused on a small model, but mm, things may fall apart once you scale the model to 500 billion, 600 billion, 1 trillion parameters. So, and DeepSeek here is a nice case study because they do have this flagship model. And if they use something in that flagship model, you basically know it works at scale. And they have their own version of sparse attention. I think they call it literally DeepSeek sparse attention, and it's instead of, so they have like a lightning indexer, like a small cheap model in a sense. Instead of for one token paying attention to all the previous tokens, it's more selective. It selects which tokens it pays attention to. So it's kind of like a mask. So you are calculating a mask over all the tokens to select a subset to make it cheaper, to make it scale sub quadratically, basically. And there have been like these types of tweaks, but it's not fundamentally changing how attention works. It's still the same attention mechanism, but how do we make it cheaper, basically? So I think that is something where people hone in on what works at the moment. But we will see maybe in 2026, maybe one of the flagship models will have a fundamentally different approach. Little companies, I mean, not little, sorry, companies, but little changes have also been made in terms of alternative architectures. So we mentioned Qwen 3 earlier. So Qwen 3 is one of the flagship models. Right now, it's maybe not at the top anymore because it's a bit older. It came out in summer. But usually, when Qwen 3 or when Qwen models came out, they are usually top of the leaderboards. Um, they had also a parallel version of their model. They called it Qwen 3 Next. And that one tried something different. They had like a hybrid attention mechanism with a gated delta net, basically to have more like a state space model approach where it's more like linear, where people are trying, but it's not necessarily like their flagship model. Like they are in parallel trying other things. And I think this makes sense because yeah, you don't want to put all your eggs in one basket, basically. You want to have a good model and then maybe on the side try something and then maybe scale it up later if it works well.
Yeah, what about continual learning? That comes up frequently as an opportunity, particularly before we got really good at incorporating in tools and the ability to do searches because models would get stale, very quickly. But there's still this interest in having a model that we can keep its training data updated. We can delete things. We can incorporate new knowledge. Like, do you foresee significant innovation in that area?
Yeah, I think this is like maybe the biggest dream in the sense of like, hey, how can we make the model improve itself? Like the biggest, I guess, achievement right now that could be made if someone finds out a way that this works. But I think right now there is no pathway to this. Like there's nothing really that is like where you would say, oh, that's the thing that will give us reliable continual learning. But that being said, I mean, there are already forms of continual learning, I would say. I mean, even something like, um, I mean, it's more like controlled. Like instead of the model automatically updating itself, people would collect data from like the recent internet or recent tasks and then carefully update the model essentially. I think it's more like that where it's not that we don't update models, but we also don't do it fully automatically. It's like a semi-automatic almost type of thing. And I think also it's like that not only because that's more reliable. So because yeah, it's risky to just update a model on new data, but it's also because of resource constraints. Because for example, I don't know how many copies of the model OpenAI has, but um, I mean, it's not you can't definitely not have a single copy per user. That would be way expensive. I mean, everyone would have to have a little supercomputer at home or like a $100,000 computer to have like a big flagship model. And so companies can't like just update everything on the fly for each user because that would be just infeasible, basically. And so unless we have ways that the models only run on the personal device, I don't think we have or can have really good continual learning essentially. Because and then the other thing is, yeah, you have to be really careful how you update it. You don't want to make the model worse. Because it's such an important, expensive product. If you just even think about feeding the data back to OpenAI and then OpenAI automatically updates the model and maybe there's a better update, it disrupts everything for everyone. And so I think it's more of infrastructure security, that type of issue. But otherwise, I mean, if you look at the reasoning training, the what we talked about, the reinforcement learning with verifiable rewards. If you run this based on correct answers and that type of setting, and you just keep it running, it is kind of a form of continual learning in a sense where you can technically just keep running this, and it's just like you don't want to. You want to be more selective, basically.
And do you think that long context or longer contexts kind of alleviate some of the pain or need to do continual learning? Like, in your case of like the personalized models, one approach is to take new information and kind of, continually learn against it. Another that I think folks have played around with is to create like personal LoRa adapters for a model. But then a third is to just put that new information into the context and use it, as at inference time.
I would say yes and no. So I do think long context LLMs, they have enabled so much recently, like where before people were building RAG systems, like the retrieval augmented generation systems, and now it's almost, I wouldn't say they are obsolete. They still are very useful if you have a fixed big database or document set, but and if you use it repeatedly. But if you're a regular user, and you have like, even if you have 1,000 page PDF, you can technically often, most of the time, I mean, 1,000 is maybe stretching it a bit much, but like a 200-page PDF, you can have it in the context. You don't need to train the LLM in terms of fine tune it on that data. You don't need to have a RAG. You can do a lot of stuff in context. And like you said, the same is maybe true for information, where you could technically just provide all the relevant new information in context. But I think it only gets you so far, because you also, as a user, have to know what to provide as information. But then if you couple that with tool use, for example, if you ask about a historical event, and let's say the data cutoff is 2025, and you ask about a 2026 historical event, the LLM can still use a web search. It can still use a tool and look it up on the web. So you don't necessarily need to update the LLM for that particular historical event. But then, if the historical event has a lot of ramification and affects a lot of other things around it, that might be missed. Then you only get certain facts from a tool call, but not that whole interaction with other data points. And I think so. It's not fully replacing the updating, but it is making it maybe less necessary to do it, or it's not necessary to do it quite as often, I think, maybe.
So, your kind of big picture thoughts on like where the field will be focused over the next year is, again, reasoning, inference time scaling, agents. Any other thoughts or predictions that come to mind for you?
Yeah, I will be curious to see. I mean, it's a little thing, but like we talked about, there is no big alternative to the transformer architecture. But there is, for example, there are things like text diffusion models, and Google, for example, they had like like a waiting page. They are planning to launch a text diffusion model, like a small. I mean, not small, but like a alternative. Where I'm really curious. It's more like something I want to see. Maybe that's gonna be replacing like the free tier of LLMs. Maybe that's a really interesting thing. I'm mainly interested in that is because there's been a lot of research on text diffusion models. So it's like a different take. Instead of generating the text sequentially, it's more like a BERT model, a BERT model, where you have masks and then you gradually denoise or replace the masks by text. I just want to see how it performs at scale, because right now most of the models are research models, and just things like that. It's nothing, I think people should get excited about in terms of cutting edge performance, but it will be maybe cheaper and faster, and maybe that will be making the, like, it's like an everyday maybe improvement for even like the Google summary and Google search, which is also LLM based, but it's not the best, and like these little quality of life improvements. I think, well, while we're recording this, is it's before the Chinese New Year, and historically around the Chinese New Year, there have been always a lot of model releases, open weight model releases. So maybe there's like a little surprise in there. Maybe we'll see DeepSeek version 4, and maybe there is a bigger change. So I'm kind of like interested in following that and seeing that. But yeah, right now, top of my head, I think we covered pretty much everything. Yeah.
Let's maybe switch gears a little bit and update us on what you've been working on personally. You've kind of referenced chapters of the book. Talk a little bit about your current book and where folks can learn more about it.
Yeah, so I think last time I was on your podcast, we talked about my build a large language model from scratch book. So it's basically the whole journey from building the architecture to pre-training a model and then also doing instruction fine-tuning. And the goal of that was not to, let's say, build your personal assistant that does all the things at home for you. So, because that would cost like $50,000, $100,000 and be a lot of work. And I mean, even though it's simpler nowadays to train your own LLM, it's not something you can do routinely on a weekend. But the goal of that book was to teach people still how that workflow works, to understand how LLMs work, because that helps you to, let's say, use LLMs better, to understand what is the context, what is the limitation of the context, how does attention work, and why is it more expensive if my input gets longer. And it's just like, if you build the LLM yourself, you kind of like get a real clear understanding compared to just explaining it in a more, I would say, free form based approach. And so yeah, a lot of people like that, and it's like a very popular textbook also for teaching now. And I was then really excited to kind of, because it's only one book, it could only cover so much, to work on the sequel. So right now I'm working on build a reasoning model from scratch, which is kind of like the sequel. There's no overlap between the books. It's basically, I mean, it can be read as a standalone book, but it's mainly focused on the reasoning techniques we talked about, the reinforcement learning with verifiable rewards, the GRPO algorithm, inference scaling, like all these techniques that once you have a pre-trained LLM, so the book starts given, so there's a given pre-trained LLM. We use Qwen 3, the smallest Qwen 3 model, and then adding inference scaling and the reinforcement learning. So the first 360 pages are already in the early access, and I'm hoping to finish. I mean, there's only one more chapter left by April. I mean, the chapter is a lot of work because you have to run all the experiments. So I've been running a lot of experiments, especially for the GRPO algorithms, because there have been so many different papers and improvements and trying them out in practice. It's been a lot of fun, but it's also a lot of work. So yeah, so I've been mostly running experiments in the last couple of weeks and months, and yeah, no, it's quite exciting actually. Yeah.
And so, can folks pick up the second book and run with that, or do you expect folks to have read the entire first book before they start with the second?
I would say either way works. You don't have to read the first book if you. So the second book, it uses a pre-trained LLM, so you don't have to pre-train your own LLM, or you don't need the first LLM to, the first book to train the LLM for the second book. So it's kind of independent like that. But the second book doesn't explain in detail the pre-training or the architecture. I mean, I have an appendix on explaining the architecture, but it's not quite as detailed as the first book. So I think if people want to understand the whole, let's say, the whole life cycle of an LLM from pre-training to post-training, I think it would make sense to read them sequentially. But you could also start with the second book, learn about inference, scaling, and reasoning. And then if you're interested in the pre-training, you can fill in the gaps later on. I think either way works, basically.
Well, very cool. Sebastian, it's been great catching up with you, and we need to do it more often than every 3 years. But thanks so much for jumping on and sharing a bit of your perspective on kind of where things are and where things are going.
Yeah, thank you so much for the invitation, Sam. I had a great time. I love talking about LLMs and AI, so, well, that was a treat, and thanks for having me on.
Thank you.